Next time you're flying down the highway, passing pedestrians on the sidewalk, keep this in mind. You are actually aging slower than they are. It sounds like science fiction, but moving through space slows down your passage through time. By simply driving your car, you are technically traveling slightly further into the future than the stationary objects around you. Now, if that's true, why don't people with long daily commutes look years younger than the rest of us? It comes down to scale. At the speeds we travel in our daily lives, this time warping effect is incredibly small. If you drove at a steady 65 miles per hour, you would need to keep driving for over 6 million years just to save a single second of aging. To see this effect clearly, you have to look at extreme speeds. This is the International Space Station. Because astronauts up here are zipping around the Earth at over 17,000 miles per hour, they age about 5 milliseconds less than the rest of us over a 6-month mission. While your morning drive won't keep you forever young, the fact that this happens at all shows that time is flexible. It changes its rhythm based on your movement and your position in the world. Why does moving through space force time to slow down in the first place? To see why, let's use a light clock. Imagine we place this inside your car. Instead of gears, it uses a single particle of light bouncing straight up and down between two mirrors to measure a second. From your perspective in the driver's seat, a light just travels in a straight vertical line. But watch what happens from the sidewalk as your car drives by. From a stationary perspective, your car is moving forward while the light travels. So the light has to trace a longer diagonal V shape to catch up with the mirrors as they move. Here is the unbreakable rule of our universe. The speed of light is absolute. That bouncing particle of light cannot speed up to cover that longer diagonal distance. If the light has to travel a longer distance and its speed cannot change, it must take a longer amount of time for the light to complete a single bounce. Because that single bounce takes longer from the outside observer's perspective, time itself inside the moving car must be ticking slower to keep the physics intact. Motion is only half the story. Gravity also changes the clock on your dashboard. Einstein realized that massive objects actually bend the fabric of space and time. Think of it like a heavy sphere resting in the center of a trampoline. It creates a deep curve that warps everything around it. The deeper you are in a gravitational dip, the slower your time flows. A clock at the bottom of that curve ticks slower than a clock placed on the higher, flatter outer edge. This applies to your commute. When you drive up a large hill, you are moving further away from the center of the Earth. You are climbing out of that gravitational dip, millisecond by millisecond, which speeds up your personal flow of time. This means every time you hit the gas pedal or drive over a hill, you are constantly shifting through different, entirely personal rates of time. This might seem like a lot of heavy physics just to describe a drive to work, but it actually has a major impact on your daily life. The maps on your smartphone rely on a network of GPS satellites, and those satellites are the daily proof that time can be bent. Moving at 14,000 kilometers per hour, satellite clocks tick slower, losing 7 microseconds daily. But orbiting 20,000 kilometers up in weaker gravity, they tick faster, gaining 45 microseconds. Combined, weaker gravity wins. Satellite clocks run 38,000 nanoseconds faster every day than Earth clocks. If engineers did not actively correct for that tiny daily time difference, GPS tracking would drift by miles every single day. Modern navigation would be useless. Einstein's theories, developed over a century ago, provide the mathematical scaffolding for the maps in our pockets. Time is deeply personal. There is no single master clock for the universe. Instead, the path you take on your daily commute dictates your own unique timeline. The same cosmic forces that shape black holes and entire galaxies are at work in your own car, quietly bending reality on your commute.